Hello?
Can everyone hear me? I see things moving around in OBS, so let me know if you can hear that in chat. Same on PeerTube. Okay, great. Well, hello everyone. It's my first time doing a proper live stream like this, so apologies for the lateness and for the technical issues that are hopefully all gone now. So this live stream, we're basically just going to do a little bit of hacking on Calendar. I'm constantly looking at your comments and questions on both YouTube and PeerTube, so please do post anything you'd like to ask or know about in terms of Calendar and KDE and that sort of thing. I'll also let you pick what sort of thing we're working on today. I do have one thing I want to do first, though, because we have quite a big bug that we have to get out of the way. I hope it looks good on your side, and if it does, then we'll just get on with it. Okay, PeerTube audio works okay too. Excellent, excellent, excellent. All right. So before I get started, are there any sort of basic big questions that you'd like to ask about Calendar, about what Calendar does, how it works, what the process has been like making Calendar, how you would like to contribute to Calendar, any of those sorts of questions? I'll be happy to answer them for about 10 minutes before we get started properly coding. There is a bit of a delay, so if I sit here just not saying anything, it's because I'm waiting for things to pop up on the YouTube and PeerTube chat. I don't think there's a live chat on PeerTube. I think it's just comments, but I should still be able to see them. I don't know if I'll still be able to see them live, but I should be able to just see them pop up. Yeah. Looks good, looks good. Cool, 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 cool. Well, for those who don't know, I'll just explain what Calendar is and how it came about while we're waiting for people to sort of come in and while you all think up your questions and type them in chat. Calendar is a new Calendar application, except for the K, that's sort of meant to be a modernized, convergent version of Queue Organizer. Our aim from the start has been to take the important and essential functionality that you would expect from a powerful calendar app like Queue Organizer, and to create a UI that's intuitive and nice to look at and can be used on both the desktop and on mobile. This sort of started way back in June, way back when I didn't know much about C++ or anything like that. And in the time since, we sort of kept adding things to it until it's become Calendar that it is today. So this sort of started as essentially a bunch of reusable components that you would use in different Kirigami apps. For those who don't know, Kirigami is KDE's convergent, meaning usable on both desktop and mobile, framework, so that you can use the same app you've designed for Plasma Desktop on Plasma Mobile. Most KDE apps today, most of the powerful ones, KOrganizer, KMail, Contact, Dolphin, all those things are made in something called Qt widgets, which is very tried and tested, but kind of old UI framework, which doesn't really lend itself very well to being used on mobile. And so that's why Kirigami exists, to provide this framework that you can use to make the same app work well on both the desktop and mobile. And obviously, like I said, KOrganizer is built with Qt widgets, so we can't use it on Plasma Mobile. There's also been lots of people who have been asking for a different take on a calendar application for Plasma, and that's how Calendar, which originally was meant to just be a bunch of components to be able to build into different Kirigami apps, eventually started becoming this full-fledged new Plasma and Kirigami application. So it's been a lot of fun. Big learning experience for me because I only started really contributing to KDE in January this year. It's been fun. I really enjoyed it. It seems people like Calendar in a lot of ways, so that's been quite rewarding. And we're getting closer to release. So we'll have a final release come out with, hopefully, if nothing goes horribly wrong, KDE Gear 2112, which is coming out in December. And we're trying to see if we can get a sort of beta version released by next week, so that you all can go and check it out without having to compile it from source, and so that you can give us a bunch of very nice bug reports that I can actually go and act on. And that being said, if no one has any questions, I'll just go ahead and get started. So let's look at our event repository. We have a bunch of issues that I need to get through. We also have bugs.kde.org. Yeah, here. And we have a bunch of quite critical bugs here as well. The thing is, because the thing is with Calendar, it's grown very quickly. So it first started as literally just a month view, and that was originally made by Carl Schwann, which has been a huge help for me personally, from a development learning perspective and from a KDE perspective as well. When I started on Calendar, it was just a month view that worked with Akinadi and sort of pulled your events from a number of online calendars, right? And in the months since, it's grown really quickly. So it's gained tasks functionality, it's gained a week view, it's gained a schedule view, it's gained a bunch of other views. I'll show it. It's gained a bunch of views, which is quite exciting, but it's also a big problem for bugs, because it's basically been most of the development's been done by me, by Carl, and by Felipe Kinoshita, who's been very helpful in tweaking UI stuff and figuring out bugs. But we don't really have a broad user base to test yet, and so we've got a bunch of views that all are broken in different ways. But we're getting through them. So this is a month view. It's a very traditional month view. It shows your events for the current month, and we've got a bunch of basically colorful squircles. So these show your events, and they span across different dates, depending if they are multi-day events, and they're sort of in order of when they happen, right? So if we pick here, this is just a test event I made. You can see all the details here in the sidebar, and this sidebar is always there. So no matter if you switch views or if you click on events in different views, this bar is always there. It's meant to be quite a consistent element. And then on the left here, you have this other sidebar that's more sort of your navigation / quick settings sidebar. So what it does is you can select which calendars to enable and disable, so you can filter them that way, filter through your events. And it's also got tags functionality, which we recently incorporated. It was a thing for tasks been the thing for tasks for a while now, maybe a month and a half or so. And then a few weeks ago, we introduced this also for all views. So you can click on something and it filters your events depending on what tags they have. So you can see this has got this tag here. So yeah. And then you can just close this and it goes back. And this works across several views. So again, you can go to the week view here. And this is also quite a recent addition. I think I added this at the start of October. And we've had several big bugs, like the hour labels here on the left. They're sort of pulled from a JavaScript date object. So when you instantiate this view, it generates a date from, I think it's something like 11100, which basically initiates a date to the 1st of February 1901 or something, and then it adds hours to it so you can get these, because that way, instead of just generating static strings, you can get localized strings. So if you have your system set to do hours in AM and PM, instead of having the 24-hour format, you get a 12-hour format. But that's been troublesome because the thing with QML that's based on JavaScript, and then you've also got Qt in the back end, which it has its own thing, and JavaScript has a date object and Qt has a date object, and there's conversions that happen between them when you pass a date object from C++ into QML, which is what Kirigami uses, right? And there is some really weird behavior with how JavaScript handles things like dates. We had a bug where when you would have your system time zone set to time zones that have summertime times. Set to summertime times. So, for example, here in Europe, we set the clocks forward an hour when it's the summertime. JavaScript think is being helpful by giving you the times that you set an hour ahead. So you would do a date and set the hour to 0, and it would give you 1 a.m. So yeah, that was a bug, and we had to work around that. And there's lots of fun little bugs that happen when you try to do things converting from Qt to QML in that way. But anyway, back to the views. We've added a few new features to the week view quite recently, so you can do things like pull this down in case you want to have a consistent and different height to the all-day header here. And we've got this nice little pull tab here that resets it. And it does what you would expect. It displays your events hour by hour. Yeah. And we've also got the schedule view, which is sort of reminiscent to the way Google Calendar on mobile works, where the default view is that it shows you the dates day by day. The Google Calendar view has got an infinite scroll, which is difficult for us because the times we've tried it, it's been quite slow. So what we've done is, for navigation in these event-focused views, we've got infinite scroll horizontally, right? So you can, in the case of the month and schedule view, scroll horizontally from month to month. You can sort of click up here and it scrolls infinitely, right? So you can go January, February, blah, 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 blah. And the same with the month view. And as you see, they synchronize, right? So you can go June, July, and blah, blah, blah. In the week view, it's slightly different. It does it by weeks, obviously. Got enough. Oh, I do have something this week. But yeah, infinite scroll, right? But not vertical. That's been quite troublesome. We've got some optimization to do in regards to both how the UI is rendered and how events are pulled from the back end. So right now, if you're on a slower computer or on a Pine phone, you might get really big stuttering when you try to load in views that are like 6 months ahead. And that's all because we have to optimize the way that these events are grabbed from the Akonadi backend. So yeah, lots of work to do, but it basically started with the month view, and then we added the schedule view, and then in, I want to say, mid-August, we added tasks, because we realized that this was going to become something that you could potentially use as a replacement for a key organizer, especially on mobile, and so we added task view. And so this works as you would expect. It sort of shows all your events here. It works like many other task managers. We tried to make it look slightly pretty with the colored checkbox and stuff like that. But deep down, it's a very traditional task view, right? Shows your events, shows you when they happen, gives you a bunch of ways to order them, and you can show your completed events here, and it pops up this window here. So as I said, Calendar's grown so quickly, and we've done so little testing that it sort of started to accumulate quite a few bugs. And today, I'm going to start off by eliminating one really big bug, which is that sometimes, randomly, when you complete or uncomplete a task, Calendar just crashes, just straight up, boom, it implodes. And that's going to be the first thing, because obviously that's quite a bad bug. And then as time goes on and we fix that, I'm going to let you all pick something that we should work on. So it can either be a specific bug that we can try to get fixed, something manageable, okay? Like if it's something that's upstream, I'm obviously not going to be able to do that in this stream. Or I can start working on a feature. So if you go on the Calendar Invent repo, you can find the planned features we have in the number 25 issue, which is here. And you can see a bunch of features that we're planning to include, hopefully before the end of this year. And we also have a bunch of feature requests that people have been putting into our issue tracker here. So if there's something specifically that you would like me to get started working on, then I'll be very happy to give it a stab if it's not, like I said, something that affects upstream or whatever. So having said that, let's go ahead. Outlook support. That's the thing. If you go to Calendar here, you can see in the settings all the different calendar sources that we... Hi, Carl. All the different sources that we support. So you can go to add a new calendar source here, and it shows you all the different things that it supports. I'm not an Outlook user, but I'm pretty sure that one of these will work for Outlook, because I've been using Outlook with Key Organizer before, and we support all the same, we use the same backend as Key Organizer, so it should work. Yeah. So, yeah, that addresses Outlook support. I've heard a lot of people request Todoist support. Issue with Todoist is that we don't have a functioning backend for that yet in Akonadi, and it doesn't use a standard way of managing tasks like a DAV resource. So I need to go in and put the work into that. I'd love to, but frankly, I don't know enough. My knowledge of Akonadi is very basic, and that's something that hopefully will improve over time. But right now, as I say, there are bigger fish to fry. Big crashing issues, improving support for the backends, for the services that we already are supposed to be supporting. But it is something that I've actually written down on our future improvement list here. So here at the bottom you can see add support for Todoist sync. So it is something that we want to support as well. But yeah, Outlook specifically should already work. So if no one has any questions or any else to say, I'm gonna go ahead and get started with the task crashing bug. So if we look at the bug report here, yes, here, 44391, and I think there's also a bug report with this in Invent, if I'm not mistaken. Apparently not, whatever. So this user, who is not Dr. Conky, Bugsy, thanks Bugsy for the bug report. They say that Calendar crashes when marking certain subtasks. So, as you will see, when you use Calendar, if you try to sometimes complete a sub-to-do, this happens. It crashes. Which is quite annoying. And at the beginning, I thought this was just random, but it's not. It's specifically subtasks. So if we open GDB and we try to run Calendar with GDB, we can generate a backtrace that tells us how this works. How to read the backtrace? Okay, good question, because I had no idea about that either when I started. So this is the task that killed our calendar. So again, kills it again. So let's do backtrace, yeah? We type BT in, enter, and it generates the backtrace. So I hope you all can see that, by the way, because it is kind of tiny. I'll increase the font a bit. So we see here that we're in the main function, and then something happens with Akinadi here, and then we get some signals from the item model here, and then where it crashes is here. So it's saying that when you do an assert, basically the program checks a value, and if it doesn't fit the thing that you want to check, it shuts down the application, right? So you can stop it from doing something really destructive if something isn't the way you want it to be. We can see this assertion is invoked here by this class, Incidence Tree Model, and the specific part is here, line 198. So we'll open KDevelop, and we'll go to the Incidence Tree Model, and we can go to line 198. And we can see that here's the Q assert, see? So what it checks is that this MUID map contains new parent UID. So what is new parent UID? It's this. And what is this? This is a Q string, so it's a string that is returned by incidence related to. So this here, that's an incidence pointer. An incidence is a type agnostic object that contains information about a specific event or to-do. So just by the way, to address any confusion, to-do is the class that we use in the back end. In the UI, we call it tasks, but when I'm talking about sort of the object, it's to-do. So the instance is the type agnostic. It can be an event. It can be a to-do. It uses KOrganizer. KOrganizer also supports a thing called journals. So we can use this to basically ensure we don't have to create different functions for different types of classes, whether it's a to-do or an event. So let's go back to here. So ignoring everything that happens above, we can see that we access the related to method of this instance, and it returns us an ID for something. Now, the related to actually returns us the ID of the instance that this specific instance is related to. So that can be, in this case, whether this instance has a parent. In the context of tasks, this would be, if you have a subtask, what its parent is. Yeah, and this returns the ID. So that you can then take that ID and feed it into a specific Akinadi fetcher, and it will get you that that instance that you're looking for. In this case, we're checking here if the UID map, which I believe is a map which is sort of like a table of all the UIDs that we have stored in Akinadi, I believe. And basically it makes sure that this map contains that. If it doesn't, and the assertion fails, shuts down Calendar. So let's check, because this block here is invoked when you get the incidence having a parent. So let's check what this returns, right? Let's build again. Give it a second. Does something. Right. And so this method is invoked when you complete or uncomplete a task, right? So let's check a random task or uncheck a random task. So task with tag, we complete it, and it returns us nothing, as you can see here, right? Nothing. So no UID. The if block here doesn't get invoked. But if we go for sub to do, which is our troublesome task, boom, you get this crash report. Surprisingly, it doesn't seem to return anything. Print UID. Why isn't it saying anything? Let's see. From here, we can also use the incidence, because we have the incidence pointer here, we can also access a bunch of other methods. So we can, for example, also just get the summary, which is basically the name of the instance. And so let's execute that and see if that gives us anything. Wait for it to compile. I swear, this thing shouldn't take that long to compile. There's something wrong with my install that makes things take twice as long as they should to compile. But anyway, let's go back to subtask. Right, okay, yes, here we go. So, as we can see, the summary. It seems to already closed the window, whatever. So the summary was sub to do, and we can see that here, and that's the parent ID. But as you saw in the UI, this task doesn't have a parent. It's by itself. So why does it have a related parent? Well, the thing is, this task used to have a parent, but at some point I obviously deleted it and didn't update the incidence. Right? So this task is now orphaned, and it still thinks that it has a parent. In the details of the task, that ID is still set as it being related to it, and when we invoke this method, it checks for that parent ID, and that assertion fails, like we said before. So how do we fix this? Well, we have to implement some way of either ensuring that when you delete a parent task, it also deletes all the children tasks, or we have to make sure that when we delete a parent task, we also make sure that the child task eliminates its relation to the parent, so that when we feed it through to the incidence tree model, this does not happen. So let's do that. The way that we handle most of the incidence information in Calendar is through an incidence wrapper, because a lot of the editing that happens with the incidences, right, in things like the Incidence Editor, that happens through a QML interface, right? So we have to pass information back and forth through QML, and the the object that that is used in C++ to handle incidence information, this class doesn't expose its properties to QML. So we have to create this wrapper that sort of interfaces with the incidence pointer in the back end, and then sends that information back and forth to the UI as things change, right? So if we change the summary for an incidence, so this is the Incidence Editor, right? Which is what you use to edit your tasks and stuff. So when you change the summary, right, you say new task. What's happening here is that when you type in the name, the Incidence Editor QML code has an incidence wrapper, which at its core has an incidence pointer. And so the incidence wrapper has what's called properties, which are exposed to QML. And these are all the properties here, right? So you can see Q property. And so they have a read function and a write function, yeah? And a notify function. So when you use the write function, it notifies, and then things that are paying attention to this property can change things around, right? They can react to changes. So when you have this property here, right, it's basically it's not directly using the incidence pointer. We have this. And so this is what we use throughout Calendar to be able to change things in an incidence. And like I said, this is also what we use in the Incidence Editor. So what we have to do is when we when we delete an incidence, we have to make sure that we tell the incidence wrapper to address the problem with the parents' tasks. Yeah. So once we do that, we'll delete. We will, for example, delete a parent incidence. The child instance will either be deleted, so we won't have to take care of it, or it will have the relation to the parent eliminated. So when we pass it on through to change things in the model, in the instance tree model, which is where the crashing occurs, then that block that does the assertion won't be invoked, and if it does have an assertion, it will pass because that instance will exist, whatever, and we'll fix the crash. So the deletion happens in the UI end with delete incidence sheet. And this is the component that you see when you right-click on something and you press delete. So this is a delete incidence sheet component. And when you click delete, what happens is that we send a signal here. So we don't actually create a new overlay sheet every single time we press delete. We have it hidden in our main.qml. So here's where we basically instantiate all the big components of Calendar, when we instantiate the month view, the week view, the schedule view, and the task view. And that also is the case with delete sheet, which is here. And as you can see, when we press delete, it sends the delete incidence signal. So let's switch back to the delete sheet. You can see here, signal delete incidence, right? And this is invoked when you press the delete here, right? So on click delete incidence, you can see here. So deletion is handled by our calendar manager, which is essentially a class that handles most of the heavy lifting. So things like which calendars are enabled. It has a bunch of helper functions that help us fetch certain incidences, delete incidences, edit incidences, and so on. So what we have to do is, before we delete this incidence, we have to modify it to either delete all of its children incidences, so that we don't get that, we don't have to take care of the child tasks, or we have to eliminate the relation. Now, if we look at KOrganizer, the way it happens here, not in terms of code, but in terms of UI, I have to enable some of my calendars. The way it happens here is that when you have a let's go to the task view, so that would be more here. Okay, ignore the silly names. Okay, when you delete something, right, it gives you the choice of deleting the sub to-dos or only that specific to-do. And when you do that, it does a bunch of stuff in the back end to make everything work out, which we don't do in Calendar. So we have to implement that, right? We have to implement that so that you can either only delete the specific events you're going to delete, or so that it also deletes all of the subtasks as well. So let's start with the UI, which some will probably find the least interesting thing because it's just adding another button. So let's go to the lead sheet. And what we use for this is a cute quick controls dialog button box component. And this essentially takes a lot of the menial work out of laying out buttons. It just provides a standardized layout for having buttons here. So as you can see, we have several buttons, but they only are visible on certain conditions. So if you have recurring events, you'll find you have a lot more choices about how you're going to delete those events. So let's find a recurring event. So for example, this one, if you delete it, you have a much wider array of options about how to delete them than if you were to delete just a normal event, right? So first, let's implement some buttons. Easiest bit, right? We have to check if the current instance has any children, or if it has any parents. Both. We check both. So actually, no. We only need to check if it has children, because we have to handle the relations there. So as you can see, this sheet uses an instance wrapper at its core. Yeah. Like I said, this is the object that essentially handles all the interfacing with the actual instance pointer, which lets us access all the details about an instance. So let's go to instance wrapper again, and at some point, obviously, to handle creating subtasks, we have to have a parent property. Yeah. So we're gonna do. By the way, if any of you have any better ideas as to how I can do this stuff, please let me know, because I'm not a very good coder. Yeah. What we're gonna do is we're gonna create a new property here. So this will give us a new property that we can access from QML to get the details about the child. So as you can see, it's a Q string. So what we're actually getting here is not the instance itself, but the ID. And we can use a bunch of methods in other classes to fetch this instance purely based on its ID. So we have parent. Let's add children. Read children. Oh. Write set children, notify children changed. So as I explained before, we have the property itself. So when we access this from QML, it will be instance wrapper dot children. So that's the name of the property. Yeah, this is the name of the property here. And then read is the function that's going to go ahead and fetch that. So sometimes you just have a variable in your object that you just want to retrieve, right? In which case your getter function, your read function, is pretty simple. But because we're working with pointers here, you want to access from the pointer. Sometimes you want to do something specific. You want to grab certain bits from a data structure or whatever. in which case you'll want to have more complex functions, and that's why we have read functions, right? Write functions, pretty self-explanatory. You set the value. You don't need them, but you have to set properties differently depending on whether you are intending to write or not. So this is optional. You can see we have some variables here that don't have writes. And we have some variables here that are actually constant, so we don't need the changed signal either. And then the notify function here basically serves to update stuff that is listening to this property. So we have children. Yeah, we need to create the respective functions here. So qstring children const, and then void set children. So wait, no, not here. So qstring children. So const. This is something that I always forget to put in because most of the time I have no idea what it does. But if I am not wrong, this is done partly for performance reasons and partly for correctness reasons. So I think I should probably ask Carl about this. I think he has a much better explanation for this than I do. Sometimes you do const variables so that it's slightly faster. You don't have to worry about whether that variable is going to get changed or not, and you can always ensure that it has the same value. But anyway, besides the point, we set the read function here, the write function, and we're also gonna have the signal here. Let's see, where's parents? I need to put it below there. Void children. Wait, are we going to do children or child? Because you can have more than one child, surely. So this needs to be a qstring list. A qstring list is just a predefined queue list, which is a queue data structure that's just like an array, right? With a bunch of helper functions. And yeah, we're going to use that instead so we can get all the children. And we're going to have to... that's right. That's another thing. So we want to use the ampersand because that does the address, I believe. Usually if you feed an argument into a function, right, and it's some type of data structure, if you don't feed it the location in memory, what it's going to do is it's going to straight up copy. And that's pretty bad for performance. So what you do instead, you take the address of that thing, right? And it just accesses that instance of that thing, which is helpful for performance, especially when you have really complex objects. You don't want to do a full copy, yeah, because that can really kill performance, especially if you have lots of calls. So we need to change these to a qstring list. Because like I said, we want to get all the children, so it needs to be a list of strings, and that will give us all the IDs. And then we need to finish typing this in. Right, so now we need to go into the actual code file. We've got the header here. This is the header and this is the code file. So let's find parent, which is here. Oh no, nothing, that's the something else, that's the constructor. So as you can see, these two functions for parents are pretty simple. They just access the parent elements, and it's going to be similarly simple for children, hopefully. Let's see. Let's first just get the functions here. So yeah, okay, those are the basic documents. So before doing anything potentially messed up, I'm going to do what everyone should do. Okay, and I'm going to check the API docs. Let's see. Develop.kde.org. And the API is such a useful resource. Wait, did I not put the ampersand in the wrapper here? Yeah, I did. Okay. Const. Right, because we're not going to modify the entries, right? So we can const it, and then that's, that's good stuff. Thanks, Carl. Such a guardian angel. Anyway, right, the docs. So KDE actually has quite a broad API documentation, especially for things relating to Akonadi and KDE Kalendar core, which is a big part of the backend of Calendar. We've also got some tutorials here. So for, I think, from January to March, I was actually working on the Kirigami docs. So if you're interested in creating your own Kirigami app, super recommended, because I wrote it. It's got a tutorial, and it's got a bunch of sections on the different components that you can use to actually create a Kirigami app. So this has really improved over the last couple of months. And it's not just been me, okay? There's been several people that have been putting in efforts to improve the docs here. So if you want to create your own Kirigami app, highly recommended. Also recommended, like I said, the API docs. So these have the more these have the all the information you need about certain classes that you're going to use in your app. Like, for instance, in this case, the incidences. So let's look for incidents. And we're looking for the KDE Kalendar core incidence base class. Let's check incidence base and normal incidents. So you'll find that all these oh wait, no, not incidence observer. Incidence base. Incidence, oh wait, no. Where's incidence base? Incidence base here. Okay. So, as I explained before, incidences are an abstract type of event or to-do, so that you can use one class to handle several different things about tasks and to-dos and events. So you don't have to have like a bunch of different functions that all do the same thing, except specifically for a to-do and specifically for an event. Same thing with incidence base. If I am not wrong, incidence base is mostly the same, except it also has this free busy thing that I'm not fully sure what it is. And we don't really use it in Calendar yet, until I figure out that it's something really important and we actually need to start using it. Hopefully that's not the case. But we have instance base here. Let's see if we can find parents, the parent method. No. Let's check incidence, normal incidence, not instance base. Parent. Yes. Related to. So we use related to here for parents. And I'm now realizing that might be a bad idea, because related to can also return children. Let's see. Rel type. So rel type is one of the rel type specifies a relation type, right? So I'm guessing you can feed the type of relation you're looking for into the method related to, and that will return you the ID for the type of relation you're looking for. Now let's check what type of incidence relations we can have. So we can have parents and we can have children. Okay, cool. Yeah, so this is an enum, and if you feed this enum into the function, it will give you the thingy, the UID. The thing is, what happens when you have what happens when you have children? Because this returns a string, right? Let's check the code. Let's see. Related to. What is related? Oh yeah, here. D pointer. Let's see. have to say, big benefit of working in free software community and on free software projects is that you can always do this stuff. If you're not sure how something works and the API docs aren't super clear on something, just go read the code. Such a big help. Right, let's see. M related to UID. So we have only 3 references and none of them are the actual definition. Okay, that's fine. Let's check the header file. Small trick if you're in the API docs. Just go to the URL here and change the TPP for H. And that should do it. Let's see if we can find this. Oh wait, one sec. That was dumb. I was adding the dot here, so let's go back. Okay. P.m related to UID. Let's see if we get any other more insights into how this works. It doesn't seem that way. Maybe I need to look at the private. I'm guessing this has a... I think this is a QMap or a QHash. Yeah, probably. Let's look at the incidence privates. Can we just wing it here? And go, I don't think this is going to work. Yeah, no surprise there. Okay, so this is part of KDE Kalendar core. Let's go into the KDE Kalendar core. Source, and then incidence. Right. P, instance space P. So we have a header file. What was the name of the variable again? I forgot. M related to UID. Does it have it? Yes, so it is. You're right, Carl. This is a QMap. Rel type and string. That's strange. Let's see what let's do what I do, which is just try to debug the hell out of this. So let's use standard output to see what happens when we try to use this method. Right, how are we going to do that? We can. I'm gonna do a quick hack. So when the instance pointer gets set, which is here, essentially when you open the incidence editor, the first thing it does is it grabs the instance pointer from the model. The model is basically just a. I'm not going to explain it in detail, but it's this thing that lets you show the data in a view, like the month view, and it does it, and it automates a bunch of stuff and makes sure everything is hunky-dory. Cool stuff. The model also exposes the incidence pointers, so we can use these when creating the incidence editor, to create an incidence wrapper that has the incidence pointer as its core, and then we can edit it from there. So this is the function in the incidence wrapper that sets an incidence wrapper's core incidence pointer. Very quickly, we're just going to add a QDebug here that gives us the result of incidence pointer related to, and we're going to make sure that we give it the rel type relation type. Calendar core incidence rel type. Wait, let me just what was it? Rel type child. Thank you, KDevelop. Rel type child. And we can see what happens. I'm as curious as you are. I have no idea. We'll go ahead and open the. Oh shoot! Oh, right. So very good. for now, just placeholders so that it compiles properly, doesn't complain. I'm just gonna make it return parent. What? Set children. Huh? What dumb thing am I missing here? Set children does not match any declaration in Q instance wrapper. Why not? Why not? Oh, is it not a? It is a const. Oh shit! Of course you can't do it. Ugh. This is a lazy bit of me coming out. I don't want to do anything too complex. How can I just like very lazily? I'll just generate a string list from a string. Let's just, I'll deal with this later. Whatever. What's wrong with this here? Set children, Q string list address children. Is that not what that? Oh, const. I bet you it's that. Const. Yeah. Okay. We're just gonna leave this one empty because it doesn't return a value anyway. Who cares? Right. Let's try that again. Right, let's go to the tasks view and edit, and that should be, okay, so it's empty. One sec, just to make sure. I'm gonna, what did I put in here? Qdebug instance. Right, so it doesn't have any children. Right, that makes sense. Right. Let's go for one that does have children. Like this one. This one, edit. Let's go back to the terminal. What? Why aren't you saying anything? This is going great. Okay. Let's see what happens if. Tell you what. We're gonna do one of those 3-level ones. So it's like a task, a subtask, a subtask, a subtask, and let's see what that returns. So let's go for the one in the middle. Yeah, I know. Oop, wrong screen. So let's create. I can just quick at it. Let's create a quick multi-level. So parent task. Let's put that in person calendar. Add subtask. Middle task. Add. And then add subtask. And then little child task. And we should see something here. So let's edit. Okay, cool. We got the parents, not the child. But why? It does have a child. That is interesting. Right. Let's look at what this does. So it returns that, right? Dot value. And we said emulated value. Okay. So what is the okay, hold on. we know from this output that this is the ID for the middle child parent. Let's look at the parent task. Edit. Nothing. No children. Little child. Edit. No children either. I mean, that one's not surprising. That's going to make things complicated. Because if we don't have any IDs, we can't check if it has children. What happens if we add several children? Does it still not return anything? Oh shit, I just closed it. I think only the parent should be stored in the events. Okay. So how do we check if it has children? So since anyway we can't store multiple children because of the limitation of KDE Kalendar core, you can use the properties of the queue abstract item model. Okay. The problem is if we do that, then if we're in say the month view, where the events are just fed in as a bunch of like unconnected occurrences, that's going to be tricky. We need some way of accessing the parent and children from within the incidence pointer, I think. Let's look at I think this queue organizer whenever in doubt, always check what other things have done. Right, so yeah, we use the incidence tree model in the tasks view, but that's not going to work for the month or week view or the schedule view. And we need something that works in those views too. Can't we, when creating a subtask, can't we just, no, like you said, it's a limitation. We can only store one string. We can't store multiple. Let's look at how to organize it does it. Delete action. How many results are there? 140, not too bad. No, this is all for deleting the calendar. Delete item. Delete incidents. Oh, delete incidents, yeah. If calendar support has incidents, delete incidents. Okay, so this is a... Or when removing an element, you can do a for each of every element inside the same calendar and then check if they have a parent set to element that just got removed. Do a for each of every element set the same calendar and then check if they have a parent set. The thing is, I'm not sure if we should still allow this, but you can actually set incidences as children of incidences that are in completely different calendars. So, tell you what, let's leave that aside for now. Let's just get on with at least having the thing where it deletes all the children instances. We need to implement that anyway, right? So let's do that first. and then deal with the other issue. Right. So let's. I'm gonna just quickly reset the so cd reset. Let's just return calendar to the state it was in, and okay, I deleted the children thing. Never mind. And let's implement the deletion of all children, right? So if we go back to the delete sheet, we can see that what we do when we have this signal here is we essentially feed this to the to main.qml, which then does something with Calendar Manager, yeah. And when we go to Calendar Manager, we go to delete incidents, we get this here, and we can see it does several. Oh wait, no, not this. Does this and calendar delete incidents. So what we do is we pass the incidents pointer here, yeah. So very simple. What we're gonna do, just for now, is before we make any changes, we're gonna open a new branch. Okay, we're not gonna push straight to master. That's a bad idea. So we're gonna check out -b work cloud task deletion crash fix. Right, we're in a new branch now, and we are going to calendar view delete incidents. Interesting inside the organizer. Okay, let's before we go any further, let's check that then. Ooh, okay. Oh, shoot, what am I doing? Calendar view delete incidents. Right, so let's try to find delete incidents. Oh, look, they have a delete children thing here, so okay, it seems this is the big chunker, the actual delete incidents that all the other ones refer to. Okay, so this is just a bunch of checks here. If force, I'm guessing, is something to ensure that no matter what, it does absolutely get nuked. And we get so quick thing on what an akonadi item is. Basically, it's like an agnostic object that you can use to get things from akonadi, and you can access the payload, which is what the contents are called, by casting it into the type that you want it to be. So we got the incidents here. Let's look. Where's this? Not recurring or instance of recurring? Question independent children. Okay, these are a bunch of checks. Let's ignore these for now. Delete. Okay, so this is for recurring events. These are like the because when you delete a recurring event, you want the user to either be able to delete that specific instance of that event. You want them to be able to delete all instances of that event, or you want them to delete all instances that happen after the one you've just deleted, right? So this is what this is handling. And this is also for recurring. And this is also for recurring. Oh, okay, so let's look at delete children. Delete children. That sounds kind of weird, doesn't it? Delete children. Oh, well, there you go. There's a function for this in mCalendar. What is mCalendar? Let's go. Wait. Okay. Oh, so it's just an ETM calendar. Cool. That makes things a whole lot easier. Like, so much easier. Okay. ETM calendar is the sort of, how do I explain it? It's like it's an Akinadi enabled calendar class that basically makes it really easy to just access the collections, which are called like the calendars, the things that store the events and tasks and so on. And there's also the also lets you access the actual items inside those calendars. So over here we see it said crap. It was the 45th match, right? Let's go back to 45. Child items, yes. Okay, so let's see. This is the ETM calendar. Child items. Child items. Oh, child instances, even better. To save ourselves the conversion from an Akinadi item object to a incidence object, I've usually just gone straight for incidence objects or incidence pointers. Okay, cool. We have the perfect method for this. Now, this is an ETM calendar, so I can't use it from the instance wrapper. The instance wrapper just handles the instance. Yeah, it doesn't do anything with the actual accessing of calendars and stuff. What we're gonna do then is we're gonna do all this in the calendar manager, which actually has as one of its member elements an ETM calendar here, right? Pointed to an ETM calendar. Right. So, how should we do this? I think what we're going to do is we are going to, like I said, do this from Calendar Manager, and we're also going to feed a variable that tells this function whether it has, if it has to delete children. Does that make sense? Yeah, it does. It does make sense. So, yeah, we're gonna add a default argument to this function that is deletes children equals false, right? Where's delete incidents here, right? Gonna add a boolean. Crap, what is that? Okay, bool delete children equals false. Again, kind of weird, but whatever. Is that how you do? Didn't mess that up, right? I'm not mixing up my programming languages, am I? Okay, whatever. Bool children. Wait, we should probably be a const. Should it? Const? It doesn't matter, it's a boolean. So if we have children, oh wait, not children, it's deletes children. Set a simple check if delete children. Then we do all the wacky stuff with the it does all the wacky stuff with deleting all the children tasks as well. And if we select the other thing, we're not gonna add another argument that tells it not to just like delete the parents of the child task. We're just gonna say if it's not delete children, it should also delete the relation with the parent. So we check with delete children, else if incidents. Wait, no, we need to check. Never mind. Like I just said, we can't check from the instance. We need to check from the calendar. So that was child incidences, yeah? Else if calendar, which is our member variable, that's an ETM calendar. Child incidences. And we need to feed it the ID, right? Yeah. We need to feed it the ID of the instance we're handling here. If child incidences and the ID. But is it? I think it's with instances. It's UID is the method that gets the ID of the instance. Why am I adding a semicolon here? Right. So else if value of type KCalendar incidence list. Oh, am I just missing? Yes, I am missing parentheses. It's not contextually convertible to bool. That makes sense. So we need to check if it's empty. I think incidence list is just based on a queue list, if I'm not mistaken. So this should just work. That's words to die by, but whatever. This should just work. It's empty. Wait. If it's not empty. If we do have, basically, if we have a list of child incidences that's not empty, we have to handle that. How do we handle it? So we need to go... Oh, one thing to find out, actually, we need to find out is if this method gives us children of children, right? So let's see. Child incidences. Returns the child, only the direct children are returned. Okay, so, woo, okay, now we need to go with, with some type of, recursion, I guess. Right. We're gonna, okay, so, we're gonna get the child, yeah? We can iterate on this list, right? Yeah, we can. We can use an iterator because incidence list. An incidence list is probably just a queue list. Right, we need to check the instance class. That's where the information will be. Incidence list. Q vector, okay. Yeah, so we can just create an iterator, right? Const iterator in this case. Yeah, let's try that. Q vector. Wait, how do you make an iterator again? Do you do that with the actual list itself? Wait, hold on. hold on. If we delete the children, we also need to delete the subchildren. Okay, so we need to start from there, right? Let's create a variable that holds our list of children, which is this thing here. So auto children, let's call it direct children just to be clear. We should probably first we need to get all the children. So the first thing we're going to do is, if we do have children, we'll recursively go through all the children of children of children of children of children, get them all in one place, in one list, and then do all the operations there, right? That way we don't have to do a whole accessing procedure, whether we're deleting children or whether we're reparenting children. Actually, no, I'm wrong about that. Because if we're deleting the parents, then the children only know the parents. Let me see if I can explain this. Delete the top parent, children, children of children. You delete the parent. You don't need to reparent the children of children. Only the okay. So it gets confusing. If we're going to delete the children, we do need to be recursive though. If we are not, then we only need to reparent direct children. I've said children so many times in the last 5 minutes. Whatever. Let's do the simple one first, the reparenting, or in this case the orphaning or whatever. For auto child of direct children, we're gonna child, which is, this is going to be an incidence because it's a list of incidences, and then set related to nothing, right? Can we just set it to nothing? I'm guessing we can. Let me double check the API docs. Set related to I'm just going to set it to nothing. And the default is relative, so I don't have to say that. So I'll just call this QString literal and empty string. Why QString literal? Because since I think KDE Frameworks 585, you can't directly cast from ASCII, which means that you need to create some sort of string object to have a string here. So that's why we have a QString literal. It's quite fast. Straight up just gives us a very simple string that's empty. Right, and that should take care of the wanting to delete the parents but not the children. If we want to also delete the children, now we have to do the whole recursive stuff. So let's do that. We have to grab the So we also need a loop here for auto child of direct children. We are going to go through and get the actual incidence pointers using these IDs, right? So ETM Calendar has quite a handy method, which is incidence, I believe. I'm probably wrong. No, incidence, and then you can feed the ID in. So you get direct. No, you get child. Wait, no, we don't need to do this. We already have a child. What? Silly me. This is getting confusing. I hate recursion. I'm too dumb for it. Do child, and we want to get the children of the child, yes? So we go with, how do we do it here? End calendar child incidences, and then we do... So how do we do the recursion? We're gonna do... Right, here's what we're gonna do. We're going to have a lambda, right? Lambda function expression. Don't know what the exact wording is. Auto delete all children. Delete all children. I'll worry about the capture later. I'm just going to focus on what it actually has to do. And then we are going to grab all of these. Okay, so we need a child here actually. KDE Kalendar for incidence pointer incidence. Oh, yeah, incidence. Right. And then we're gonna grab all the children. So we're gonna go with need access to the current object. So calendar, yeah. I'm double checking myself so much because it's hard live, you know. I know that someone who's watching me is laughing at me. Like, what an idiot. Child incidences, and then incidence. And then we're going to loop through these. So for auto child in direct no in oh, I need to define this. So auto all children, and for auto child in all children, yeah, we are going to kill them, which we can do by this, which we have here. Oh, silly me. Let's do the UID. And this is in the wrong place. Let's put this here. Delete incidents. Child. Destroy the child. Right. All the children gone. So, if you don't know, Lambda is super useful. You can have functions within functions. And they do a bunch of other stuff that I don't know. We do here, we have to the recursion bit is what gets me. We have to go to each child. Actually, we can do this with this function here. Can lambdas call themselves? I think so. Man, when we have to start talking about recursion, I get scared. You know, this is how big crashes happen. Right. So can I like draw something? I need a diagram. We want to go through each child. Each child is a list, and we want to go through each child. So we get children of children, right? This is confusing. I'm also like such an idiot. Right. While Incidence has this is where we use the thing we did before, where it's Incidence UID, and then not empty. What is empty? Oh, silly. We're gonna call this lambda again. Risky. So for each child, we need to call this again. Not this. Want to call, yeah, delete all children of this child. Variable delete all children declared with its use type auto cannot appear in its own initializer. That makes no sense to me. As in, I don't understand what it means. Okay, that's out the window. Let's not use a lambda. Let's use a separate function altogether. Okay, let's not mess around with functions now. Delete all children. Wait, no. Let's make it a method, because we still need access to member variables. What am I looking at? Oh yeah. We're gonna add it somewhere here. Where's delete? Delete. Okay. We're not gonna make it invocable. We don't need to. Delete all children. And then we just need, what, an instance pointer? Yeah, an instance pointer. Yeah. Now everything's comparing at me. So that's calendar for students instance. Then we paste this in, right? Let's get rid of this for now. So we want it. Let's align this. Oh, sorry about that. Oh wait, this needs to be here. Leave this at the start, yeah, because we're going to check all the children. Are you all bored yet? Delete all children, right? We're going to invoke it again to go through all the children. And let's think about it for a second. So no, let's check first if the child has children, right? Because if it doesn't, we want to delete all, because if the problem is we can't reach up from the parent from within the child. So yes, that's what we're gonna do. Right, we're gonna get the we're gonna use the we're gonna check the child here, right? We're gonna say if why do we don't need this wall anymore, right? I might live to regret that. Yeah, that makes sense to me. Totally makes sense to me. We're gonna check if the child has children itself, and if not, then we're just gonna go ahead and delete. If it does, then we're gonna go ahead and do the recursion stuff. Yeah. Yeah. And then once that's done, once we've gone through and killed all the children of this child, then we'll be here with the incidence parent, yeah, at the top, and then we'll go through deleting the ones that we've gone through here. I realize me saying here is meaningless, but let me explain again. What we're doing here, we're feeding it a pointer, right? We want to delete all the children of this incidence, yeah. And then we're getting all the children of that incidence. We're looping through them. We're checking if they have any children themselves, yeah, which we do by checking is empty. I'm going to put this here. So if it is empty, we recur, right? We start this function again, but with a child. If it doesn't, then we just continue, yeah? Once this loop is done, right, and presumably all the children have been killed off, man, so weird. We start deleting the children of the instance we fed in. Yeah, it all makes sense now. All is good. All is hunky-dory. Okay, now we just gotta try it. If delete children, then we're just gonna go ahead. This is back to the function that gets invoked when we press delete in the delete sheet. Okay, so we're gonna do that. We call delete all children, and we call it with the incidence. Yeah, infanticide. Let's go ahead and start testing this, because this should theoretically now work. In theory, hopefully, maybe. Let's see. Let's go to the delete sheet. This has probably been done better before somewhere else, like in KDE. I could probably just copy their code and it most likely work better, but let's see if it works. Who knows, you know? So we want to create new buttons. So we're just gonna straight up copy paste. So this standard delete button always appears. So we just want to change the text depending on what we're trying to do here, right? So if it's a recurring event, let's not worry about that for now. Let's just worry about if it has children. So we need to find some way to check if it has children. So we need to go back into the instance wrapper. So instead of getting children, no, wait. No. We need to check if it. What we need to do is we need to tell the function that we just created in the calendar manager if we want to delete children or not. But to do that, we need to know if that instance actually has children. So we need to figure out if that instance has children, which means what we're going to do is we're going to create a new function in Calendar Manager that tells us if that instance has children. So let's go to Calendar Manager here. QInvocable. Bool. So we just want to know if it has children or not. Has children. Oh, children. And then we're gonna feed it an instance, yeah? And then here we're gonna, it's gonna be very simple. It's gonna check if the list of instances is, the list of child instances is empty or not. So basically it's just gonna be a function that does this. Calendar Manager has children. And then we're just going to feed it the pointer. Right. And yeah, just this term. But not child. Instance here. Okay, so I should do that. And semicolon. The cool thing about having a bool. The cool thing about having a an invocable function, in case you didn't know, is that you can actually call it from QML. It's exposed to QML. All the other functions aren't. So let's go back to our delete sheet. Actually, let's commit while we're at it, okay? I don't want to mess anything up and lose this work. So we're going to git add. I think we're going to have to git clang format. What was that? Git clang / format? I think that's it? Yeah. Git add again. And git commit. Added delete functions and stuff to calendar manager class. And then we're just going to push that. Oh, I have to set it upstream here. Boom. Crap. Yes. Okay. Cool. So we just saved our progress. Checkpoint. Back to the incident sheet. Delete incident sheet. So we now have to know whether we have children with the incidents we're deleting, and we have an invocable function that handles this stuff. What we're going to do is we're going to make this a property here. A property in QML for a component is basically just a variable that you hold there, right? and you can access it from the outside. So we're going to make it a Boolean. We're going to make it a has children. Yeah, and we're going to do a ternary conditional. So if instance wrapper, so if we have an instance wrapper, if it's not null, if it's not undefined, then it's calendar manager dot has children incidence wrapper dot incidence pointer null. We're gonna make it sorry, we're gonna make it false. It doesn't like it when we set it to null sometimes. I don't know. And then here, what's the delete incidence sheet. So we're gonna do another conditional here. So delete incidence sheet dot has children. That's not a very good name. Let's say incidence has children. Incidence. Oh crap! Where did I edit it? Here. Incidence. So if it has children, we want the button to say I18N, by the way. What it does is it makes your strings translatable. So when translators come to translate your app, all these strings get fed into somewhere. Not quite sure where, but they can go ahead and translate those strings. So for user-facing strings, always add I18N. Right, if it has children, then the default behavior we want is for the children to be not deleted. Right? What did we set in Calendar Manager? Let's see. Calendar Manager here. Yeah, I think the default is false, right? Yeah, false. We are not going to delete the children by default. So if it has children, where was I? Delete children. If it has children, basically what we're doing with this bog standard delete button is always giving the most like standard possible thing to do, right? So in this case, that's going to be delete. What's the button say? Delete all, right? Oh, so we don't need to have a new one. So we just have. We just check if it has children or if it has recurrences, and then we just say delete all. If it does have children, I'm going to have a new button. We also need a new icon, I presume. Cuttlefish, super handy piece of kit. Delete all. Oh, delete all. Is there anything? Group delete. Yeah, but it's the same icon, isn't it? Okay, remove. None of these icons are super descriptive. Anyway, we'll just go with group delete. Put it here. Oops. And so if wait, we just said I'm dumb. We just said that the default behavior is to not delete all children, right? So what we want is for we're gonna have a new button. This is getting messy. This is going to be delete all. Yes, delete all. This is going to be delete all. Let's do this first. Delete all. And then visible only if the instance has children. And on clicked, we're going to have a new signal. It's going to be delete, including children. The bar incidence pointer, and also a bool hold on. Is there a more elegant way to do this? Probably. Okay, tell you what. We're gonna have a new signal that is specific for deleting events that have children. Okay. We'll go into the details. I'm not going to go into the details of handling both instances that have children and are recurring. I'll have to deal with that. But we're going to do bool deletes children. Right? I'm going to go back here. I'm going to make this delete. What does Organizer say? Organizer. What's the label say for that? Delete. Delete only this. That's pretty good. Pretty exact. Delete only this. And then we're going to delete incidents. Actually, no, we don't need this. Do we? No, we don't. Because we're going to delete with, we already have a default argument in the method. So, forget about that. We're not going to do that. So delete only this, default, right? Yes, cool. Here we need the so if it has children, or if it's recurring, then delete all is the label, and then if it has children, we're going to do delete incidents with children. Right. Getting there. Almost there. All we need to do now is hook up this signal to actually do something. Which is here in main.html, which is where this sheet is instantiated. Delete all children. We're gonna do calendar manager dot delete incidents. I'm gonna just copy the rest of it. It's the same. But we're gonna also add true here because we want to delete all the children. Okay. Time to test. Place your bets. Is it going to work or not? Compiling. Ooh, moment of truth. Crap. Can I assign to non-existent property on delete all children? Did I misspell something? Delete incidents with children. Oh, okay. Done. main, and here. Place this here. Paste. Execute. Second try. Let's see. Okay, I need to re-enable my calendars. Oop. Right. Moment of truth. Gonna delete the middle task. Crap! What's going on? It's just giving me the default delete. Wow, holy crap, it's also giving me a bunch of string errors. That's not cool. Time to debug. Yay! Okay. Let's see if Incidence has children changes. On Incidence has children changed. No. Yes. Incidence. Console.log Incidence has children. Blam. Let's try that and see what happens. See what goes on. True, false. What? Why? Why are you going false? Huh? That is strange. I'm missing something, I think. If we have an instance wrapper, right, then we invoke that calendar manager method with the incidence wrapper's incidence pointer. If we don't have an instance wrapper, we get false. Huh. What? That's okay. Let's see. On incidence wrapper changed. Let's console.log this mama. See what happens there. Right, it's in the wrong monitor. Cool. Very cool. Let's see, delete. True! Right, so... What? Okay, let's try this. Let's try just checking instead of just checking incidence wrapper. Instead of checking for a truthy or a falsy value, let's just check for undefined. So if it is not undefined, it should give us that value. Should be the keyword once again. Nope, still false. Why? Why are you doing this to me, man? You're welcome, Emmanuel, though. Right now I'm just kind of trying to figure out what the hell I'm doing wrong. I am confused. Why is it going to false? You know what? Let's do that. Let's see what that does. Let's, instead of using a ternary, let's just use a straight if. Nothing. I am very confused. I guess so. I guess 99% of the time is just pulling your hair out. Yeah. See what? I am not sure why that is happening. Not happy. What's Calendar Manager doing? Maybe I just... I'm so dumb. Of course... Of course it's gonna say true if it's empty and false if it's not empty. So it's fine. I just need to add an exclamation mark and now it will work. Trust me, 99% of the time I spend hours on something, it's always something dumb and stupid like this. It's one line or one character. God, okay. Yeah, it's just gonna work now. Let's see. Delete instance sheet. Let's undo all this stuff. And now it'll work fine. If it doesn't, I'm gonna be very sad. Oh, it's in the wrong screen again. Moment of truth. Yay! Of course it works. Cool. So let's do what we were trying to do from the beginning, which is delete the middle child task here. So delete all should also destroy the little child task. And it did. Yay! Okay, that works. Cool. Delete all now works. Now let's try the sub-to-dos. Bing bong. Right? So let's try to delete the parent task. Okay. Didn't delete bing bong. Now, moment of truth. Oh, it's been like 2 hours, okay, but our original purpose was to fix the crashing of sub-to-dos that have had their parent deleted while the sub-to-do has survived. So, will Bing Bong survive? Will it kill Calendar? Crap! It crashed! Damn it! Okay. Let's go back to Calendar Manager because that's where all the hot stuff is happening. So close yet so far, you know? Let's see. Right. Direct children is not empty. Yeah? Which means it does have children. We're going through them and we're setting the related to be nothing. I don't understand why that doesn't work. Let's go back to the root of the crashing, which, as we see when we run GDB, is still going to be so where's the one we just completed? Bing bong, that's the one that crashes. So yeah, it's going to be still going to be here. Yeah, incidence tree model 198. Incidence tree model 198. Let's go and do some more Q debugs here. Incidence.summary and incidence. Let's just need parent ID. I could taste victory, but it was snatched. Let's go back to Bing Bong. Where's Bing Bong? Oh, yeah, we uncompleted it, so Bing Bong is here. So this has not taken effect. Oh, this is dumb. This is stupid. So, right. One thing you have to take into account when you're working with incidences is that when you change an incidence, it's not going to automatically change the incidence in the calendar. You have to set that change to apply in the calendar. Dumb oversight. So in the calendar manager, we have a method that deals with modifying incidences, and the last thing it has to do is submit the change to the calendar that that incidence is in. So all we're going to do is just do that again. So we're going to go to calendar manager. Yeah. And we're going to find where this happens, edit incidents. Ooh, that's can we just, we're going to go the lazy route, okay? We're going to just yeah, do it straight from here. Modify incidence. And we just submit the incidence pointer, which is child. And now it should work. And I know I said that before, but it should work now. So let's wait for it to compile. Wow, it's been 2 hours and 15 minutes of trying to fix this. This is why I always end up going to bed at like 4 a.m. Right, so parent. We're going to create a parent task. Let's start from scratch. Parent, and then at subtask child, and then we're going to add another subtask. Child. Oh. Child. Okay, moment of truth part 2. I'm going to delete child. Okay, so child has survived. It works! It works! Child survives and doesn't kill calendar. Cool! We did it, folks! We fixed the bug, kinda. This is the first part, really. I mean, we also now need to figure out how to do event deletion when we have recurrences too, but it works. And I'm happy. I'm very happy. So let's commit this to the Git branch. I'll do, if anyone has any questions in general, because I know this has gone on for quite a while, if anyone has any questions in general about Calendar, about me, about KDE, my thoughts, whatever, anything, I'll do a little Q&A session now. If no one has anything to say, then we can just end it there. Yeah? I'm especially open to, if anyone is curious about how to start contributing or whatever, very happy to answer those kind of questions. So, yeah. Okay, first of all, I'm gonna git add, I'm gonna git commit, incidents, deletion, handling of children. Now works properly. I know that message doesn't make a lot of sense or whatever. Git push. Okay. Well, I'm here to answer questions. I originally intended for this bug to take like 45 minutes or like an hour, and it's taken a lot longer than that, and I wanted to show off more, working on more features and whatever, but that's fine. We can just leave that for another stream. Please, I'm really happy to answer questions if anyone has any, in chat. Hallelujah, we're all, yeah, I know. I was getting a little bit nervous as well, because it's, I didn't want this live stream to be 3 hours of me basically just messing around trying to fix one bug. But it's been 2 hours of me trying to fix one bug. Yeah, so, well done, and thanks for the work on Calendar. Thanks for your support. It's been really gratifying to see how many people have come out and sort of, thanked me for working on Calendar. It's, something that really was, it was first just a Google Summer of Code thing, and then it became something that I've kept going because it's fun. And, people seem to really like it, so that's very fulfilling. So thank you. Great to see a channel broadcasting KDE development. Yeah, I think, personally, I don't watch live streams a lot, but I know people enjoy watching people work on this kind of stuff, and I thought it was probably a good idea to show how and explain live how things work with Calendar, because I find a lot of the time a big barrier to getting people to actually contribute to open source projects is the fact that there's this really steep learning curve to figuring out how that software works, how all the tooling works, and so on. So doing streams like this where we go through how crashes occur and how bugs are there and how features work, I thought that would probably be a good idea. Great video, thanks. Question from PeerTube. Have you got plans for the next episode? Okay, I'll keep refreshing PeerTube. Plans for next episode? Not really. I'm very happy to take it in a direction that the audience, so chat, you guys want me to go. I announced this with not a lot of time beforehand, so it's sort of being, okay, I have to do this, so I'm just going to live stream myself fixing this one thing. But I'm very happy to hear any thoughts and work on any specific features that you guys want me to. This is just as much for you guys as it is for me. Very happy to work on all this stuff. When will Calendar have no bugs anymore? Never. Never. The problem with a Calendar, as I explained before, is that we add so much stuff every week, most of the time, that we don't have time to properly test. And at some point, that's going to have to slow down a bit. We're going to have to really focus on fixing bugs more. And we're starting to do that. So there was a big chunk of that in KDE Review, which finished this Sunday. 2 weeks where we mainly focused on bugs. and that was actually fun as well, you know. And we got a lot of stuff fixed. Especially little niggles, you know, things like the time picker not working properly and the date picker not working properly, that sort of thing. So bugs are decreasing, but they will never be fully gone. They're always there, you know. Sorry. Any more questions? It's 23 past, so if it's been, how long has it been? It's been like 2.5 hours. Well, if no one has any more questions, I'll give it another minute, and then I'll be very happy to end the stream. I'd like to contribute to KMy Money. Where could I go to get started with that? Good question. Have you worked on KDE projects before, or is this your first time? Do you have any experience with Qt? Do you have any experience with any other stuff? Because depending on the answer to that question, my answer will be very different. A project as it matures and as long as it's maintained tends to receive less features and more bug corrections. Yeah, true. True, very true. Is Kalendar integrated with Kmail? You probably mean Contact, right? Not yet. We have been trying, but so far we have had lots of problems. I couldn't get it to work on my system, and Carl, who's in the chat now, he managed to get it to work once, kinda, in Contact, but it didn't really work. It hasn't worked since. It's tricky because it requires a bit of a mix of Q widgets and Kirigami things and bejangling them together. We're working on it. We're working on getting Calendar in Contact, but not yet. Not yet. If you're talking about integration with Kmail specifically, you probably mean things like creating to-dos from emails and that sort of thing. In which case, no, not yet. But it's on our plans. There are several things like that, being able to open .ics files directly and importing events. That doesn't work yet. Other sort of like drag and drop stuff that also doesn't work yet, but it is in our plans. Okay, so no, I'm guessing was if you've had any previous experience with Qt widgets. In which case, I recommend you first of all get started with creating your own basic app, because that will give you a good feel for how things work together. There is a tutorial in the developer documentation for KDE that goes through making a Qt widgets app, and I'm pretty sure KMy Money is a Qt widgets app. Let's check. KMy Money. Why am I going to images? Yeah, that's a Qt widgets app. So if you go into documentation here, you'll see getting started with KDE Frameworks. This goes through how to make a very basic sort of like text editor using several parts from the KDE frameworks, and these are all made with this is a Qt widgets app. Yes, so I recommend you go through this tutorial, understand how all the different bits work, and once you have completed it, you'll have a much better idea of how you can start working on and hacking on KMy Money. As Carl says, there's a matrix channel for KMy Money. That's going to be a great place to ask for help, ask about how the broader architecture of the application works. And Tom, as the maintainer of KMy Money, is apparently very nice. So he'll be very happy to answer your questions, I'm sure. So yeah. We have, if you're interested in contributing to a Kirigami project like Discover or Calendar or NeoChat, We also have, like I said at the beginning, the Kirigami documentations, which are quite new, quite detailed, and those will help you get started creating your own first Kirigami app and understanding how a lot of the components that you'll use to build up the UI work and what they're useful for. So, yeah. Thanks for the detailed answer. You're very welcome. Okay, Carl says KMI Money is working on porting some stuff to QML, so you might find that if you want to help them with that, the Kirigami documentation is very useful. Yeah. So yeah. Any other questions? I'm going to check PeerTube now because I kind of have to keep refreshing it. It's not like live comments. Seems no new questions there. I'm going to say let's keep it going until 8:30, which is in 2 minutes. So quickly, get your questions in now. If, by the way, you have any concerns about the documentation, be sure to bring them up. I think there's more people working on the documentation these days, but I will also be happy to address any problems that there are in the Kirigami doc specifically, since, you know. Okay, hello Slavik. It's probably a Kanadi issue, but do you know why Google Calendar events to which I'm invited but I didn't accept yet aren't displayed in Calendar nor Key Organizer at all? No idea. I use my primary account is Google Calendar, but I don't usually have invited events, so I haven't really tested this. Thank you though. I will make sure to try to reproduce it on my end. Really helpful thing you could do is submit an issue on our GitLab with some details about the steps that show off this bug and details about your system, and we will get to it eventually. Yeah. Some of the more difficult upstream bugs, those will take longer, mainly because the Akanadi team is working on their own set of bugs and they have their own priorities, and really the only person that has like some knowledge of Akanadi on the calendar team is Carl, and I want to get into that, but I haven't yet, so I'm not really sure how to fix bugs in Akanadi, but one way or another we will get to it. Yeah, so please open the issue so we can keep track of it. Yeah. Okay, well, I think that's it. It's 8:30 now. I want to thank you all very much for coming by. Hope you had fun, and I hope it was at least a little bit instructive. Do let me know if you have any more questions. You can send me an email, or you can reach out to me on Matrix. I'm gonna post my Matrix name, so you can reach out to me on the KDE Matrix. Thanks to the stream, you're very welcome. Thanks for coming by. And you can also join the calendar room, where we will very happily answer any questions, any concerns, listen to your feature requests, and so on. So here's the link. I'm going to post it in the chat for our calendar room. And yeah, if you want this to be a regular thing, let me know. Very happy to do this more often. And yeah, thank you for coming by. Let me know if you have any ideas for the next one, if you want it to be the next one. Okay, bye-bye now. Bye-bye. Thank you for coming by.